We have this car here. This car is sitting at some height above this loop. This car will drive down this hill, and it'll go around this loop, and we define the minimum height here that allows the car to go through this loop without falling. So I'm going to first set my zero level, and I'm going to say my zero level is at the top of this loop here. So this will be my zero level. Now I'm going to set up an energy equation. Energy 1 is equal to energy 2, because there's no work of friction or work of air resistance. The energy before is just the gravitational potential energy of the car. Since I said my zero level was at the top of the loop, this will just be mgh. This will be equal to, it'll just be the velocity of the car at the top of this loop, which will be 1 half mv squared. Now we don't know this velocity. To find the velocity, I'm going to have to use a part of uniform circular motion. It'll look like this. This will be my loop here. The car will be at the top of the loop. When the car is at the top of this loop, it won't have any normal force because it'll just barely make it past this loop without it falling down to the ground. This car will have gravity. This will point down. It'll be mg. Now I'm going to use Newton's second law, F equals ma. This will be F centripetal, and this will be A centripetal. If you remember, A centripetal is equal to v squared over r. So it'll be Fc is equal to mv squared over r. The centripetal force is just gravity, so it'll be mg is equal to mv squared over r. The mass will cancel. I'm going to multiply the radius over to the other side. We'll get v squared is equal to g times r. Take the square root, and we'll get that v is equal to the square root of g times the radius of the loop. So I can plug that right into there. I'll first cross out these masses. I'll get gh is equal to 1 half times the square root of gr. That's squared. This will cancel with the square root, and we'll get gh is equal to 1 half gr. The g's will cancel, and we'll get h is equal to 1 half r. And that is your final answer. Thank you for watching.